In this video, we're going to be talking about the Catholic Schools 2010 Extension 2 Trial, question 7a. The question reads, 5 identical rings are to be placed on 4 fingers of one hand. In how many ways can this be done? Now, this question might look simple, but it is one of the few questions in this exam that most people would not be able to get correctly. How do we start? Well, I like to say that let's say each of these fingers is called A, B, C, and D. A, B, C, and D. They're 4 different fingers, so you must distinguish them. I also like to think about rings as ring numbers 1 to 5, even though they are identical rings. We'll be able to deal with that later. But in terms of looking at it, it seems like it's a good idea to start off systematically. So let's talk about the first ring. Now, each of these rings will have 4 fingers to go for. So they have 4 options, and so does ring number 2, and so does each of the other rings. So the logical conclusion for that is that, well, 4 options for each ring, 4 times 4 times 4 times 4 times 4, 4 to the power of 5. What's wrong with 4 to the power of 5? Well, let's have a look at the scenario here. Let's say ring number 1 got finger A, ring number 2 got finger A, ring number 3 got finger A, so there are 3 rings here. Ring number 4 got this finger, and ring number 5 got this finger. Now, that's the same as saying ring numbers 1, 3, and 4 went on this finger, 2 went on this finger, and 5 went on this finger. So, as you can see, 3, 1, 1 is counted, well, at least twice, considering what I wrote down as an equation here. So you might think, okay, well, we're in a situation of counting the same thing several times, and because there are 5 rings, why don't we just divide our answer by 5 factorial? Because, you know, that eliminates all the repetitions, right? Well, unfortunately, apart from the fact that you can't actually divide 4 to the power of 5 by 5 factorial, this isn't going to work. But what is the real reason that dividing by 5 factorial doesn't work? Because when you divide by 5 factorial, you overcount, which means you're counting 5 factorial times. Here, I'm trying to convince you that we didn't actually overcount 5 factorial times. You know, you might think, okay, if you had ring number 1, ring number 2, and ring number 3, sure, if you have one ring on each finger, and there were 5 fingers, so ring number 4 and ring number 5, then of course you'll get overcount 5 times because you can have 2, 1, 3, 4, 5, or any other arrangement of that.
Could the students of 10-6 mathematics, 10-6 mathematics, please come to the front office now? Students in 10-6 mathematics, can you please come to the front office right now?
Someone's got in trouble. Anyway, back to this question. Now, when you overcount 5 times, you need to have one ring on each finger. Well, what happens if we say we have ring number 1, 2, and 3, and then maybe we have a 4 and a 5 on the same finger here, like so. So 3, 4, and 5. Okay? Now, in this case, I'm trying to tell you that this configuration hasn't been overcounted 5 factorial times. In fact, what actually happens is that ring number 3 got this finger, finger D. Ring number 4 got finger D. Ring number 5 got finger D. But if we thought it was going to be counted 5 factorial times, then we would have considered 5, 3, 4, right? Because 5 sort of got in a different order. So instead of saying 1, 2, 3, 4, 5, we say 1, 2, 5, 3, 4. Well, 3, 4, 5 and 5, 3, 4 on the same finger is not a multiple count from 4 to the power of 5. Because in both cases, rings 3, 4, and 5 all got onto finger D. So dividing by 5 factorial is not going to be a correct quick fix to this question. So what I want to emphasize from this point onwards is that when you're doing these questions, the biggest skill you need to have is the ability to count systematically and accurately and clearly. So this is how we're going to do it. I've drawn some containers here denoting each of these 4 fingers, and I'm going to show you the systematic way of finding every single configuration of putting the rings on each finger. So you can have 5 rings on the first finger, no rings on any of the other fingers. 4 rings, 1 ring on one of the other fingers. 3 rings and 2 rings on another finger. 3, 1, 1. 2, 2, 1. 2, 1, 1, 1. Now you can't actually have 1 on each finger because there are only 4 fingers, not 5. Now this is the point where you have to realize that each of these configurations I've done in sort of a descending order. I've done it in a structured, systematic way. I didn't go, oh, let's have 5 rings, now let's think about 2 rings. No, I went from as much rings that I can put on one finger without repeating what I did before. At this point, you have to now find how many ways can you actually have 5 rings on one finger? Well, there are only 4 fingers, so 4 ways, right? Stack all the 5 rings on the same finger. What about 4 and 1? Now, if you can look at this working out carefully, you'll notice that I actually made a mistake while doing this video using the pink pen, right? I thought originally that if you wanted to have 4 on one finger and 1 on the other finger, we should just do 4 fingers, choose 2 fingers. But choosing 2 fingers doesn't actually show where the 4 and the 1 went. So the proper way of doing this is, again, systematically, step by step. So the step was this. Pick a finger where you want the 4 rings to be on. So let's just say we have this finger. There are 3 fingers left. Pick a finger for the other ring, for the 1 ring. So 4 choose 1 times 3 choose 1. Using the same logic, pick a finger for the 3, pick a finger for the 2. Pick a finger for the 3. Pick 2 fingers out of the remaining 3 for each of the 1s. Pick 2 fingers out of 4, 4 choose 2, for the 2, 2, 1, and then pick one of the remaining fingers. And lastly, pick 1 finger for the 2, and, well, you only got 3 fingers to put each of them with 1 ring, so that's actually one of the easier ones. So in the end, when you add all of these together, these 6 different combinations, you're going to get 56 as your answer. So hopefully you've learned a lot from looking at this question, from listening to my explanation, and I suggest trying out other questions because every combinations question is a little bit different. You must be able to count carefully and not rely on any form of formulas. In fact, we didn't even need to use the choose notation here. Good luck.